All right, so transition metals and ionic compounds, they start off and use this idea of Roman numerals. And so hopefully you're familiar with Roman numerals and what they stand for. If you're not, just the clock here can kind of help if you understand the face of a clock and how it would work. So this is 1 o'clock and 2 and 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so each of those symbols represent numbers in Roman numerals. So we're going to use those Roman numerals when we go through and we kind of name our ionic compounds with transition metals. So ionic compounds are done the same way, okay, same steps. We cross, we put the charges above, we cross, we reduce with ones and reduce it down if we can, writing out the ending with the IDE. All right, ionic compounds are done the same way with transition metals, except Roman numerals have to be included with the metal. And in general, really, we'll see kind of why. So let's take this example here, Fe3 plus and O minus. If I go through and I take a look at 3 plus, 2 minus. Do you notice with iron in this case, iron could actually be two separate ones. So iron, it says here, it could be 3 plus, but it could also be 2 plus. So iron could actually have two separate charges to it. And if you look at the legend that's up on the top, we have a most common ion charge in your periodic table. And the other one says other ion charge. And so transition metals sometimes can have more than one charge. And so if you take a second and just look at your table, there's a few that are there. Atomic numbers 24, 25, 26, 44, and another one 78. Okay, just have more than one charge. So we have to specifically say which charge it has in order to accurately write out the compound. So in the example, I have to tell you that it's Fe3 plus for you to know which one to pick. Because if I don't, then we don't know if it's 3 plus or 2 plus. So we do it the exact same way. We put 3 plus above, we put 2 minus, we cross the charges, and in this case, I'm going to have Fe2 dropping the negative, O3 dropping the positive. So Fe2, O3. After that, you write out the name of the ionic compound, including the "ide" at the end. Same thing as before, we have iron oxide, but I have to include where the transition metal is, and I need the Roman numerals to do it. So in this case, iron 3 has to be in there because I basically have to say that iron has a 3 plus charge associated with it. And so I have to include the Roman numeral after the metal, followed by the non-metal ending in oxide. Okay? The Roman numeral will only ever go in between the metal and non-metal. It'll never go at the end, it'll never go at the beginning. Non-metals don't carry multiple charges, only the transition metals do. And so if you run into a compound that can have multiple charges, you have to specify which charge is being used. So in this case, I'm saying iron 3 and then that oxide. So, as an example, what would be the chemical formula for chromium 2 sulfide? So let's take a look. I'll get the second, pause the video, try it out, see if you can come up with what it would be, and come back when you're ready. All right, so chemical formula for chromium 2 sulfide. So chromium 2 tells me that chromium is going to have multiple charges because it has a Roman numeral. So let's take a look first and see what our elements look like. Okay, right from your periodic table. And if I take a look and see which one we're talking about here, it's talking about chromium 2. So I know I'm using the other ion charge. I'm not going to use chromium 3 in this case. Sulfur only has one. It's in group 6 going down the list, so we know that it needs to take in 2 extra electrons. So if I were to write this out, I'd start off with my symbols first. So Cr and S, we'd write the charges above each one, 2 plus, 2 minus. We're going to cross them over. And so I'm going to have Cr2S2. Notice that I have 2 and 2 here, so I can divide this by 2 and reduce it. So I'm really going to have CrS. So that would be my formula that would work for chromium sulfide, or chromium 2 sulfide. So you should have enough skills right now, enough tricks that you could go through and continue on with this topic. I do have a couple of questions for you to try. Page 193 to 195, there's questions 1 to 10 that are there that just practice going through some things with ionic compounds, drawing board diagrams, and that sort of thing. So good luck, and let me know if you have any questions.